Here we have a problem involving two functions combined in a composite function or a series of composite functions. Just reading the question, it says let fx equal 4x minus 3 and gx equals x squared plus 2. And what we want to be able to find is f of g, g of f, and peculiarly g of the inverse of f. Now, moving forward, what I want to have a look at is finding the inverse of f, because this will just make things easier. And what we do when we're finding an inverse is we swap x for y. So what we're going to have here is x equals 4y minus 3. And what we will have here, if I put this in terms of y, will be x plus 3 on 4. Therefore, if we look at f of g, this is f gx, and this will equal 4x squared plus 2x minus 3, and we'll expand this out, 4x squared plus 8x minus 3, and that's our answer for fgx. If I look at g of f, this is g fx, and what we would have here is 4x minus 3 all squared plus 2 4x minus 3. Now we would have to expand that out, so that's going to become 16x squared minus 24x plus 9 plus 8x minus 6. And this will give us a term 16x squared minus 16x plus 3. So when we look at g of the inverse of x, this is g f inverse x. We're going to do a similar thing where we're going to use the bracket and we're going to expand. Now there's a lot of expansion that goes on in particular with this term, and you've got to be able to recognize what happens when you square both the numerator and the denominator. However, if I push it a little further, and what I get is x squared plus 6x plus 9 on 16. And then I expand this, but I'm going to expand it so that it's going to be all over 16, because that way we have a common denominator and we can combine the terms. And what I would get here is 8x plus 24. Now, when I come to resolving this function, what I get is 1/16 x squared plus 14x plus 33. And this is correct. So checking in the back of the book, all of these are correct. Now the next part of the question asks to look at the transformations from gx to fx. So what we're wanting to do here in part B is to take gx equaling x squared plus 2x and transform it so that it becomes gx image 4x plus 3 squared plus 2 4x plus 3. Now the transformations are actually hidden within the brackets as shown here. However, when we talk about our transformations, we want to be smart with how we do them, and we might set them up so that we take this factor of 4 out of the whole brackets. Let me just get rid of that. And then we have this function written in quite a long form, but it helps us in terms of our transformations. So when I talk about this 4 and this 4 here, this is a dilation of a quarter, so the transformations. So this 4 and this 4 is a dilation, and I'll just write this in shorthand. Dilation of, or dilation by a factor of 4, okay, from the y-axis, meaning that it's a horizontal dilation. And then this term here, the plus 3/4, means that we have a translation of 3/4 to the left. Okay, and they're our transformations for B. When we have a look at C, and what we're trying to do with C is we're trying to transform y equals x squared to y image x squared plus 2x. And what I might do with y image is I might complete the square here. And there's a good reason why I complete the square, which you'll become familiar with after we have completed the square. So what I get here, and we can see easily that my transformations are pretty much all translations. And I have one translation here of this x plus -1, which means that it's a translation of 1 to the left. And then I have this -1, which is a translation of 1 downwards.